Okay, hi everyone. Last talk of the day, but we'll try to keep it light and just have a discussion. We'll very quickly just do a very brief presentation, like around 8 minutes of our introduction, like what was the work that we did with the Ink team, and then we'll move on to more of a discussion related more of a discussion part. So starting off, I'll just introduce the speakers. So I'm Joao Santos. I'm a project manager at OpenZepplin. This is Jota, one of our blockchain security researchers, and that is Hernando, one of the core developers for Ink.
Yeah, so I don't work at OpenZepplin, just
He
to
does not.
clear that up.
So to quickly explain our work a little bit, our approach to exploring such a massive code base like Ink that has so many things that it interacts with, such as substrate, such as a bunch of extra palettes. Just our approach was based on two things. First, technology exploration, and then the technical review in and of itself, right? So to onboard into such a massive code base and look at it from a security perspective, but also to make recommendations about what could be improved in terms of developer tools, in terms of educational materials, in terms of overall direction, maybe also overall direction of the Ink project. We just went through and did a comprehensive study of Ink, of substrate, of Polkadot in general, and then some other periphery tools for developers, some onboarding materials, and then we actually went into the low-level review specifically of Ink and of the cargo contract CLI. But I'll let Jota go into more detail about it now.
So yes, we all from OpenZepplin come from the Solidity/Ethereum ecosystem. So this was actually a very cool thing to do, to come to a new ecosystem, learn new languages, learn new libraries, and learn everything that you guys have been building for so long. And we come up with all these concepts that we didn't know about, but some concepts that we did know about, for example, smart contracts. And the Ink team came to us asking for us to do the security review, where we, basically reviewed as much as we could in a period of time. Starting with Ink and cargo contract. Basically, Ink is a DSL that runs on top of Rust that allows anyone to be able to write smart contracts, in parachains, and write smart contracts in Polkadot and Kusama. But of course, a programming language always needs tools around it so that you are able to see the contracts that you have, the contracts that you deployed, the functions that those contracts have, and of course to interact with them and to do monitoring stuff. So we also take into account in our review the cargo contract CLI command line interface. So yes, basically the cargo contract CLI provides a lot of command line commands for developers to be able to do all these interactions in a safe and good way. The threats that we took into account when we did this security review was taking into account reentrancy, which is basically the ability for attackers to re-enter a contract by interacting to an external contract. Access control, which is basically malicious actors to be able to access to functions or to functionality that they shouldn't be able to access to. Arithmetic issues such as underflows and overflows that usually there are a problem in Solidity. But randomness, which is basically if you have some sort of functions that work with random numbers, that you're doing it right and they cannot be manipulated. Proxy selector clashing and storage collisions, which are very related to the concept of upgradability and the fact that you might have two contracts that interact with each other and if you're not careful about the communication between one contract and the other, you might have problems in accessing either certain functionality or certain variables. Denial of service, so basically actors being able to stop the system to be accessed by other actors. External data source dependencies, we try to look as much as we could of all the libraries that Inc. was using for us to be able to assess whether they were secure or not. Very also related to dependency hijacking and phishing, which is more like something that we took into account, but we couldn't go very deep into. But it's more related to whoever interacts with smart contracts from a normal website to just double check that nothing wrong is going there and it's not open for phishing. So one of the first things we did in this process was to check, to do a feature comparison between Inc. and Solidity, focusing our time on upgradability. That is a feature that is very well known in blockchain. We know that blockchain is immutable usually, and if you are developers and you introduce bugs, sometimes it's very difficult to get rid of those bugs on time. So upgradability comes to fix that by changing the code. And then other stuff such as inheritance. How is inheritance used in the Inc. programming language? How composition to talk to other contracts is used? Whether they had function modifiers, so that to add extra functionality on top of a function that is being called, for example, for access control, to check whether the caller that is calling that function should be calling that function or not. And fallback functions, which are usually functions to send funds to a contract, or if you don't have a specific implementation in your contract, a way of communicating with that contract anyways. We also worked on suggestions for tooling improvement. When we went through the cargo contract, actually at OpenZepplin, we not only performed security audits and built smart contracts, we also went through a lot of stages in which we were working on building CLIs for developers to have basically an easier life when developing. And all this experience, we could also apply it for cargo contracts. We suggested some stuff such as commands to see all available accounts that you have to interact with a smart contract, see all the deployed instances of a contract, the addresses where they are deployed, and also the methods that you can call from those contracts, to create a differentiation between commands to read the state of variables that in Polkadot, when you try to read one of those, you have to make a transaction. That transaction will have a transaction ID, and that might cost money, versus doing a dry run, which is just reading the state of a variable of a particular smart contract versus the other type of calls that I just mentioned. They already had the functionality for upgrading contracts, and we also suggested, like, well, developers might want to upgrade these contracts, maybe not through a multisig, but do it directly. So it's good for you to have a command to do that. And then other commands around maybe if your system has a lot of contracts and you want to build them all at once, instead of having to do that for each contract, that's also useful. So basically, general recommendations on how to make the tool better for developers and easier to use for developers. We also went through some education suggestions, something that we found out at OpenZepplin for bringing developers and auditors to the Ethereum ecosystem, is that there are certain things that you must do to make what you're building attractive. For auditors, it's usually bug bounty programs. If you're building this library and you want it to be secure, you can bring a bug bounty program and pay hackers to try to break your project. In this case, would be the Inc. programming language. Build and promote CTFs. If you want auditors to move from other ecosystems to learn Rust and Inc., it's great if they can do it in an interactive way by trying to hack code that is written in Inc. And also competitive programs, audit programs for people to compete and earn money to make the ecosystem secure. And for devs, it's interactive tutorials, which, yeah, it's basically some sort of like crypto zombies like application where you can learn from building cool stuff and playing games. And developer grants. If you want a new feature in Ink or you want a protocol to be written in Ink, maybe what you can do is incentivize the community by giving them grants to build a specific thing using this technology. And other than all these things, we also looked at the code and tried to find as many vulnerabilities as we could. Of course, not from an auditor perspective. We didn't perform security audit as we usually do, but it was more like a security review, and we tried to compare as many things as we could with all the Solidity problems that we faced over the years, and we could find some interesting vulnerabilities around custom selectors. When you so there's a feature, a very interesting feature in Ink, which allows you to set a selector for a function. So basically, you can be called John, but if I don't want to call you by John and call you by Joseph, I should be able to do it through a selector. So the important thing is, even though you're called John, I'm just going to call you Joseph. Well, we found some issues around how they were using custom selectors. Some in upgradability, some issues around how they were managing storage between the previous version of the contract and the new version of the contract. When you upgrade a contract, maybe you not only want to add more functionality, but you also need to add more storage. You need to declare new variables to be modified or accessed by these new functions. And yeah, basically more issues around that. And yeah, later in the presentation, we're going to show a QR code of the whole report where you're going to be able to find all these findings and read more about them.
So yeah, now in this section, we're just opening this up for a Q&A. And if you have any questions about, what we did for the security review and just overall questions about maybe comparisons between Ethereum and Polkadot, please ask away. We have two industry experts here to answer your questions. So go ahead. If not, we also have.
I was going to say, what sort of questions are you hoping folks will ask, or what?
Well, questions maybe around like how Ink works compared to Solidity, maybe the process of like OpenZepplin coming to a new ecosystem, like all sorts of things, right? So if you're curious about how the security engagement was, like we're here to answer. If not, we also have questions.
Yeah, what is your perspective of this assessment, the security review, and I know if you have any thoughts to share with us.
Yeah, so there's a couple things. Like for one, I was quite happy that we even got OpenZepplin to take a look at our code because it kind of almost legitimized our project and the efforts we were doing. Like Ink really started off as an experiment. Like, can we do smart contracts in Rust? Is WebAssembly a good target? And we've been working on this, for a couple years, and now actually having, like building a community and getting, again, like legitimacy from like real auditing firms that, hey, this is like actually, more than just an experiment. That was, one of the biggest takeaways for me. And then, yeah, overall, like working with the OpenZepplin team was quite pleasant as well. Definitely a bunch of professionals.
Yeah, for us it was also a very, very interesting engagement, basically because we're very used to audit Ethereum-like projects. So basically smart contracts that run on Ethereum, on L2s, but everything very Ethereum and Solidity related. So for us it was a challenge. We learned a lot about Polkadot that we didn't know about, everything that you can do with Polkadot that you actually cannot do on Ethereum. We were able to learn Rust, not from scratch because most of us already knew Rust, but it was a nice process to learn these things. Of course, a lot of questions came up in the process. One that I wanted to actually ask to Nando is, so after learning about all these things in how Polkadot works, how parachains work, what runtimes are, what palettes are, the fact that you can build palettes such as smart contract palettes. My question was, why would you build a smart contract language when you can actually do this like in a lower level? Why bring smart contracts to the Polkadot ecosystem?
For one, job security, right? I got to stay busy somehow. But no, there's like a lot of different trade-offs when you're going from like runtime development to smart contract development. So with one, you kind of get like a lot more performance and a lot more, I don't know, customization. That's like the runtime development route. But it is also a bit of an uphill battle. Like even though it's all written in Rust, doing runtime development requires much more effort, and there's a lot more foot guns kind of exposed to you as a programmer. Whereas with smart contracts, you can kind of, keep the damage a little bit more contained. It's a lot easier to get started with. You can kind of deploy like smart contracts much more easily than you would be able to spin up, let's say, 10 blockchains. And then there's also the whole composability aspect. Like with smart contracts, you can fit a ton of different transactions in a single block in a way that you might not be able to do in a runtime-centric world. Yeah, so again, it's all about trade-offs. And if you watched my talk from yesterday, you can kind of take a little bit of both as well and kind of combine, runtime development with smart contract development and do a little bit of a hybrid approach. And just improve your application experience that way as well.
Do you think it also will bring more developers from other ecosystems to build on Polkadot by the fact that if they already know how to build things with smart contracts in Solidity-based blockchains, they should be able to do so?
Yeah, for sure. Because it's like you're not learning a whole new paradigm as you might be with runtime development. Like, you have the same patterns, even the same kind of like, security vulnerabilities, right, exist in Solidity and Ink. So that makes it that somebody coming in from Solidity is very like comfortable already with the paradigms. The only thing they need to do is learn Rust.
Let's maybe open up
Yeah.
for some questions from the audience. I see
I got
two
it.
hands there.
Thank you, guys. We've seen a lot of development happening in like on Solidity, a lot of developers building on top of Solidity, and we've also seen a lot of critic of Solidity because of that. There has been many attempts to build like a better EVM language. So I'm wondering, like, what's your perspective on the things that were done right in Ink compared to Solidity, if any?
I can get that one. So when I joined OpenZepplin and started working with Solidity, I noticed that it was a very immature language in so many ways, like basic stuff such as if you do a subtraction between a number A and a number B, and A is lower than B, then you would create an underflow, and for like tracking balances, that can be terrible. Those things we faced a lot in our journey as security researchers at OpenZepplin, even though a lot of things are getting better, but you can clearly see that it's still an immature language. Something that blew my mind while I was doing this security review, something I really, really liked, is that it's built on Rust. It's on top of Rust. Rust is a battle-tested, well-known language that you can use for many, many things, not just smart contracts. You can build software for kernels. You can build microservices in your backend. You can do basically whatever you want. And from the security perspective of an auditor, reading Rust is actually very, very clear, because in the end, when you try to break a system, you're just looking at the logic of it. If I can just abstract how it works under the hood by I don't care how Solidity works. Well, actually, I have to care about how Solidity works because it has a lot of problems that I have to take into account. If I see a subtraction, I have to take into account that there might be an underflow in previous versions. In Rust, it's kind of like I don't need to take care about any of these problems. I just have to focus on reading the code and finding vulnerabilities that the developers introduced. Do you think you're accruing interest daily and you should be doing it hourly? Well, maybe there's a high severity issue there. You're letting someone to access a particular function and they shouldn't be able to access it. well, I don't have to take care about anything about the language itself, but just like the implementation, which for auditors is amazing because it's literally just reading instructions in English and trying to see if they are doing what they have to do or not.
Yeah, I'm gonna echo that as well. It's just like the fact that we're leaning into Rust and leaning into all that safety just also does provide like a bit of relief as a programmer. And then in Ink, we're also streamlining a lot of patterns that kind of happen in Solidity. So for example, with upgradability, we can kind of upgrade code in place with Ink. Whereas in Solidity, you got to set up all this weird proxy stuff and upgrade behind the scenes. You know, that adds more code, it adds more complexity, it adds more surface area for attacks. So yeah, just making it easy and simple for developers to write code and do what they need to do.
Yeah, and actually I believe that one of your implementations for upgradability was by using proxies and using delegate calls. And you also had a set code hash functionality, and we ended up having a call, like a 1-hour discussion where it was like, why would you use proxies here? You don't need any of like this Solidity style stuff. Just use set code hashes that should be way more safe in many, many ways.
Yeah, that was actually funny because yeah, we did have these multiple approaches, but because we were so like in the trenches, we were just like, oh yeah, we need to support this proxy stuff, but we never took a step back to say like, okay, do we really need to do it? And we'd like, I don't know, kind of invented like a different way of doing it that was better without really realizing.
Yeah, and proxies are not only used for upgradability, but also, for example, if you have a wallet and you're a company that provides wallets for people, and the wallet is massive and you want to deploy that and that costs money, you can use proxies as like a minimal proxy that reads a certain big contract that is very easy and very cheap to deploy. And that's, for example, another use case of proxies in the Solidity ecosystem. But we also figured out that it wasn't needed when you work with Ink because of how it works, the process of deploying the code. You just like deploy the code and the code is already there. The money that you had to spend to do that, you already did it. You only instantiate something that is already there. So actually, it's another feature that was like a very weird workaround in Solidity. And for us in Ink was like, oh, this is like built in, amazing.
Thank you. Is that clear? Okay. I think I saw another hand. No. Okay. Does anyone have any extra questions? Okay, then maybe we can dip into our backup conversation starters here. I'll ask the question now.
A casual get to know me kind of activity that you're having? Okay.
Okay. How do you see the journey of building a security community?
Yes, I guess I was going to pitch up more to you guys, but I don't know. From my point of view, it's really trying to connect, the right sort of developers with the right sort of auditors, and kind of making sure that everybody's like, I don't know, like one, paid, and two, educated. And this kind of has to be done in lockstep. So if you're trying to get like new projects into an ecosystem, they're going to want, some assurance that there's a security firm ready to like look at their code. But security firms aren't going to look at code unless there's like cool projects in the ecosystem and money and all this stuff. So from my point of view, like I've been working on this kind of treasury-funded initiative called the Incubator, which is trying to fund all these different actors, and OpenZepplin's, one of the partners in that. Just trying to get everybody started at the same time, making sure there's money and code out there for auditors to review, and then also some educational content as well. Again, on the code side, making sure people know how to build like secure code, and then on the auditor side as well, like making sure there's content, make sure that they know how to learn Ink and all this sort of stuff.
Okay. Next question. Do smart contracts help with adoption?
I think we already answered that one.
A little bit. Going farther.
Yeah, that's a good one.
Why does OpenZepplin want to be in the Polkadot ecosystem?
Well, Gallo, that is here, already gave a talk about how we see the ecosystem and how we understand that decentralization and the open economy, that is what OpenZepplin is trying to protect, is and will be multi-chain. And we understand that Polkadot has a great community of builders. It has a lot of companies behind that are working a lot in making this ecosystem better. Every single part of the things that you're building are very interesting, and we understand that this is going to be key. For us at OpenZepplin, at the moment, Ethereum is just like a way, but we don't know if it's going to be Ethereum in the future. For us, part is going to be, yes, Ethereum, but we understand that other blockchains are as important or even more important, and we have to keep an eye on all of them because they're part of the decentralization, and we want to keep them all secure if we could.
Thank you. We have time for one more question. So maybe... Oh, there's a question there.
Hi. So could you say that Ink was designed so smart contracts feel closer to Solidity 1 than other Rust-based smart contracting platforms like Cosmos Watson or Solana and things like that?
Yeah. Yeah, so we wanted to make the paradigm as close to Solidity as possible. It's got the same synchronous structure. It's kind of got the same layout of the constructor and messages and how you do things. And again, that was just to make it simple for developers to think about how to write smart contracts in Rust. There's other new projects that are trying to maybe go for an asynchronous model or trying to do something exotic, but that wasn't part of our set of design goals.
So the main reason was to have easier adoption from the current developer.
Yeah.
Thank you.
And from the perspective of someone that used Ink a couple of times in the last few months, it's literally like that. It's writing in Solidity for me. Yeah. It's just about thinking about the logic because Ink, the DSL already has all the features. If I want to write a function that is going to be the constructor that is going to be run when I deploy a contract, I have a macro that is constructor. Okay, perfect. I use this macro and this function now is a constructor. And now I just focus on writing what I want the constructor to do. It ends up being a very simple process and very, very similar to Solidity. So I think it fosters people from one ecosystem to, if they want to move to this ecosystem, to do it with ease.
Okay. No extra questions?
That's okay. Yeah. Let's give another round of applause for the team. Thank you so much.